Hi everyone, today we are going to discuss slope-intercept form. In other words, y equals mx plus b. Sometimes you've heard us say this is solve for y, and we are. We are isolating the y variable on the left side, and then we are putting it in order with the x variable and b, the y-intercept. So you have our slope next to the x and the y-intercept on the back end. So first we're going to solve where the y variable is on the left side. We have 2x plus 4y equals 12. Since the y variable is on the left, I'm going to leave it there, and I want to move everything else to the right. So I need to move this 2x by subtracting 2x from both sides. But on the right side, there is no x variable for me to put this with, so I want to put it out by itself on the end. That leaves me with 4y on the left. And since we are using y equals mx plus b, I want my x variable next, which is negative 2x, and then the plus 12. I now need to divide every piece by 4. So I have y equals, and I'm going to reduce 2 over 4 to 1/2, negative 1/2 x, and 12 divided by 4 gave me 3. It is now in the form y equals mx plus b, and I can pull off my slope. The slope is sitting in front of the x. It is negative 1/2 here, and it does not include the variable x, only the number. The y-intercept is where it crosses the y-axis, and that is the positive 3. So our y-intercept is 3. Or we can write that as a coordinate 0, 3 because we are talking about a point on a graph. If there's no constant on the back end or in an equation, then when we solve, we only get y equals mx. There's no b there. That means here in this example that our slope is negative 3, since negative 3 is with the x, but since there are no constants in the problem, the y-intercept will be at 0, or the origin point of 0, 0. Now, this problem is with y being on the right side. Since we want y equals mx plus b, where y is on the left, just switch the entire two sides. The negative 7x would go to the right, and the 4 minus 5y goes to the left. Now begin your problem. We need to subtract 4 from both sides. Now once again, there is no constant into the problem, so I do not want to put it under the x. I have negative 5y is equal to negative 7x minus 4. I now divide each piece by negative 5. So y equals a positive 7/5 x plus 4/5. We want to leave everything in fractions, no decimals. So our slope next to the x is 7/5. Our y-intercept is 4/5, or in other words, the point 0, 4/5. Okay, so let's try a couple more just to make sure that we have it here. Okay, so we have negative 3x plus 5y equals negative 18. Since our y is on the left, we want to add 3x to both sides. I'm going to stick it out by itself. 5y is equal to, I'm going to bring my x's up front, so they're positive, 3x minus 18. And then I'm going to divide by 5 here. So y is a positive 3/5 x minus 18/5. Okay, we want to leave everything in a fraction. All right, so for this problem, the slope is then 3/5, and the y-intercept is a negative 18/5 here. Okay, so let's do the second one. Now our y is on the right, so that means I want to switch sides. So this entire 6x minus 4y is coming to the left, and the 30 is going to the right. So the entire side switches. Okay, we're going to subtract the 6x from both sides. Negative 4y is equal to negative 6x plus 30. I divide by negative 4, so y is equal to, now this becomes a positive 6/4, and this becomes a negative 30/4, and now I want to reduce this fraction since they can both be divisible by 2. This is 3/2 x, okay, and I'm sorry, 30 divided by 4, okay, you can put that in. Oops, sorry. Okay, so that would be divisible by 2 as well, 15/2. So here our slope is 3/2, and our y-intercept is a negative 15/2. So you always want to work in fractions unless they're asking you for decimals. And that's how we solve for y, or put it in slope-intercept form.